Hi, my name is Rudraksh, and in today's video I'm going to talk about my artificial intelligence project for my AI class. The project is basically a genetic algorithm, and it essentially performs a function of finding the path with the least distance for a traveling salesman problem using genetic algorithm. Here I run the program for 50. I run the program 50 times, and with each time I run it, there are about 100 generations for which it runs. With each generation, the two major processes happen. First is the mating, which is a natural process which happens with each and every generation to produce new generations. And mutation occurs randomly based on chance. We can see that in this variable probability of solution mutations, which is 0.1. I found that this was a sweet spot, and at this point the mutation isn't high enough that it creates a lot of problems for the next generation, and it isn't low enough that it doesn't even play a role in the next generation. So 0.1 is just about right. Now, understanding the code for mating, the process is such that in order to create a random mating process, so that the child or the offsprings that are created from the child from the parent strings have the genome on a random have a random part of the genome from each of the parents. So with each process of mating, there is a random number that is generated, and based on that random number, the splicing occurs. There are two separate splice points, and which cuts the entire genome from of the parent and the child of the parents into three sections. These three sections are then arranged in a random fashion, and that forms the genome for the child. Now there are three different cases for which the random the which for which the splicing for which the arrangement of the splicing occurs, and this is based on a random number generator. So randomly the offsprings are created in any one of the three flavors. Then for the mutation process basically is taking random positions and swiping them with the other position, so as to create like a random so as to emulate the process of random bits up and down, which is what mutation does essentially, is like flipping random bits from 0 to 1 or on and off. That's what we're trying to do by swapping individual components of the genome. That's what the mutation is. Now, the GA also learns as it goes from generation to generation. So the process of learning is done with the help of bonus, which acts as a positive and a negative reinforcement. So if the two successive cities are in a distance of, let's say, 300 units from each other, or less than that, then the bonus increases. And if you have a and it is set up in such a way that if you have three successive cities or four successive cities which are consistently less than 300 units from each other, then the bonus increases the bonus increases for each of them. So you have you can have four times the bonus which you can have for, let's say, two cities together. As well as if the cities are farther than 600 units, then the bonus reduces. So it might be that you might get a lesser value, or that it might be a negative reinforcement for the GA to have cities that are more than 600 units far away from each other. It'll train it so that it forms cities, it connects and finds those cities that are clustered together, so that minimum amount of distance has to be traversed, and all the distance for a certain domain is traveled first. All the cities are on a certain domain are traveled to first, and then it goes to the next section of the graph. And for the cities that are between 300 to 600, that spot it has a bonus increase of 0.25%. It's actually kind of 0.25 in value. So what it basically does is that the bonus gets added with a bonus count. That is, a bonus is a static value that is 150, and it gets multiplied with the bonus count. So it gets multiplied with 0.25, let's say, then it increases by 1/4. So that way, the positive reinforcement with each generation tend to make the GA go towards attempting or go towards finding cities that are clustered together or close enough to each other and improving the results over time. Now, I did perform the experiment for running 50 different set of cities and running each of them with about 100 generations each, and finding out the total distance at the end of 100 generation. That distance I did for all the 50 cities, and found out the mean and variance for it, as well as for the GA which doesn't have any positive or negative reinforcements, which is normal GA and has normal mutation and mating without any positive or negative reinforcement. I did the same experiment, took 50 different city sets and run each of them for 100 generations, find out the final total distance of the city of the cities for each set, and find their mean and variance. Plug that data into the database and found out and used the help of with the help of null hypothesis, found out if we can reject or accept the null hypothesis. For now, I'm gonna show you the final spreadsheet. As you can see that this is the 50 different. This is the total distance at the end of 100 generations for each run of different cities. This is the mean. This is the variance. Similarly, for the one without any positive reinforcement, the genetic algorithm gives this as the mean and this as the variance. When we plug it inside the data, when we plug the data for 50 sets, we find out that for the third hypothesis, that is u1 not equals to u2, we get the result that do not reject the null hypothesis. This essentially means that the two set of data show that the two GAs are essentially similar on a long run. They are centered at the same point, and that there is no significant there is no significant difference or deviations between the results produced by one GA and the results produced by the other GA. So essentially, there was not much difference that was created with the help of positive reinforcements. Now let's run this program and whether check for, let's say, 1,000 generations, create a new set of cities. As you can see that this is the GUI. Each black dot represents a city, and the red line represents the path connecting the two cities. A green line represents the path connecting the first city and the last city. Now from here we cannot know if this was the first city or this was the last city, but at the end of 100 generations, you will see that as the progress bar reaches 0, you will see that this connection, which is a lot jagged at this point and a lot of confusing, and also you can see clustering of a lot of long distances connection between the cities. I mean, this connection is really long. At the end of 1,000 generations, you will see that the distance reduces, and these two cities might no longer be connected together because they do not optimally they give the optimal solution to the traveling salesman problem. So let's run them and see what happens. So you see now these two cities are not connected anymore. Instead, the connection path has been reduced to a very simple and a small set of connections. So you see, if the clustering happens at this of the cities, then they are all connected together. Again, a clustering, then they are all connected together with short paths between them. And where there is no other path available, there is an inevitable long path. Then and only then the paths are long between the cities. And you can see that the total distance is 14,000. If you increase the amount of the amount of generations and create a new city, then you might get a better result at the end of the process. The only thing is that the process is very time consuming. It has a very high time complexity, so it's going to take a lot of time if you increase an amount of generations for each run. But the solution that you get also becomes better and better. The most optimal solution that I received at the end of my entire run for more than about 100,000 generation was about 10,000. It plateaued at that point. It was going down, but it plateaued at 10,000. So yeah, it's about 10,000 mile was the final result that I received. As you can see, 11,571 is the final result of the GA, and and this is the first and last, or the last and first, whichever it is, and this is the final connection sequence. So yeah, this is the work of the GA essentially, and it solves the traveling salesman problem. So the code is posted online. Thanks for watching my video. Have a nice day.